make sure your voice is heard. Just speak to us. It's an open discussion. I got the pleasure to just introduce the topic, but this is no presentation, and this is the topic for all of us. Perhaps the reason was because we do have a little bit longer experience in Europe using the RGBs in the broad sense, and yeah. So why do we want to harmonize things and make standards? I mean, it's very obvious, right? Oh, I'm playing with this one. Ah, it's you. Sorry. So this equals pain, right? What you're seeing here. So we want to have different colors, but the same connection to whatever we do. And I'm still seeing it here.
This one's fine.
Ah, okay. Now I talk to this side more. Okay. And yes, finally, we have very nice, consistent view over the full globe regarding the RGBs in this sense, but much more than that. This is taken from UMIT-View. So if you type view.umitsat.int, you have multi-mission products, and you can see that that snapshot I took. There are some lines and differences between different sources of the data, but luckily this is one of the examples where we are on the same page. We all use this product and we're happy about it, and this is a good example of where we should or we should not aim to get in the future. So this is just to kind of make you realize. So if you think about the timeline here, before now, now means like plus minus several years. Globally, we had maybe severely capable of really doing the RGBs. So there was not much knowledge or an experience around the globe before now, and future may make us diverge from now in terms of what are we gonna use and how we're gonna approach the use of RGBs. So now is maybe really kind of in a history of RGBs and satellites. Now is maybe the good moment to really focus to the question how to standardize, or if we even want to standardize the RGBs, because down the line 20 years, if we decided to standardize, I'm afraid it's going to be very late, or it's going to be much more difficult. So now is a good moment to do that, and blah blah blah. It's just the flow of thought Maria and I had preparing for this session. So if well, I'm no expert in making standards, but we thought of making a first step to make sure why we would have standards and what would standard mean. So just to make everyone on the same page, what is the experience from Europe? This is only what we can share. I invite any of you to share your own view on how and why we would do a certain RGB in a certain way. Is there a classification of the RGBs? How to build a good RGB? Yeah, and we spoke about the conceptual color assignment, for instance. Is this all valid? I'm not sure, Maria, how do you feel about these topics? Did we make it clear, or would you like to say a few more words about this? How to make a good RGB? What would be the steps? The classes, potential classes of RGBs, like synoptic scale, feature, fetching RGBs, etc. Would you like to say a few more words before we? Okay, just okay. You have a PowerPoint as well. Okay. Do we want to get it? Okay, maybe just a few words. We wouldn't like to go into details, but hold on there. So once we're on the same page, what the feeling is about how we should structure the RGBs, maybe we should think about what are the, I put here post severi. This was actually copy paste from discussion with Maria, so it's very European centric. Sorry about that. It's kind of the RGBs that we haven't seen and we're very excited about, and a bunch of you guys made it happen. So maybe okay. Well, we can live with that. That's the last slide anyhow. I'm just going to keep it for discussion. So you did a wonderful job across globe to come up with the new RGBs we've never seen or were capable of producing. So we would like to discuss among these which are good candidates if we want to do any standardization, what to do with them and how to handle. Yeah, keep in mind unexplored, so that we've heard ideas about, I don't know, matching the lightning data with the imager data and do RGBs with level 2 products maybe. Yeah, it's possible to find the redundancy between all the products that we know. And yeah, the naming, we've touched on this topic many times this week. So I would like to kind of, yeah, have maybe not even 70% as Bernie was mentioning, but to have some idea where we want to move ahead and how to do it. We'll not go through each and every RGB and decide about the names. We had the one name successful naming this week, or two, I think actually. We named a fire RGB, and we renamed our natural color RGB to day, land, cloud RGB. That we'll see. We'll try to make it fade away and make room for new ideas for the natural color RGB. So that's it from my side. I think it would be worth maybe to start with Maria, and maybe just a few words. You don't need to show anything. Maybe you can come up or take a microphone for the online listeners, and just reflect a little bit on. So there is a reason why we kind of converged logically to what Maria will say. But I won't go into reasons of why exactly, but there is some logic in the things of how to create and handle RGBs. We had 20 years to think about that, and we have some ideas. So Maria, please.
So sorry if I will speak, say two evident things. So for process and building a good RGB, we have 5 steps. So the first step is determine the purpose of the product. The second is based on experience and scientific information, select the 3 appropriate channels or channel differences, which provide useful information for the specific purposes. And the third is pre-process the single channels or channel differences to ensure that they provide or emphasize the most useful information. This is the proper enhancement. The force is assigned to the 3 spectral channels or channel differences, the 3 RGB color components, and the 5th. It's also very important that to review the resulting product for appearance and effectiveness.
Mm-hmm.
So this is the principle. And why RGB standardization? So we a set of standard RGBs should consist of good quality informative RGBs with high color contrast, which get the best out of the data. And it is also very important to keep the RGB color schemes comparable across the sensors, yeah, like you showed it. And of course, using standard RGB is important that because if we use standard RGBs, that it will be much more easy, fast to understand images created by other meteorological surfaces, and it also make easy to create effective training materials or visualization softwares, which can be used anywhere. So how to choose standard RGB? It is very important that limited number of RGBs. It should consist of limited number of RGBs because the forecasters would not like too many of them. And they should also contain RGBs for several different applications. So optimally for each important application, if possible. And also important that the appearance of the RGBs should be enough different from each other, that if the color schemes are too similar to each other, then it makes difficult the interpretation, so it can be confusing. So I made a little bit classification or how to grouping of AIMS applications. So it's very good if we have RGB type or types, which helps the large-scale synoptic situation analysis, and to have RGBs for cloud analysis, and also environmental RGBs, which provide information, for example, about dust or volcanic ash or fires. As we said, the color side, and yes, I think that is because what I have here are which standard RGBs are from Severis, but I don't want to go from one to one.
Yeah. I think, correct me if I'm wrong, but I don't think we will have here the chance really to make a standard set of 20 RGBs in the next 60 minutes. Maybe we can, let me know. Yeah, there's 2 sessions. Well, how do you feel about approaching? Okay, yeah, we could go into gist of it. I'm happy that we stay productive and we move forward. Emily? Yeah, absolutely. Just any comments are fine. If you're against standardization, if you're pro, if you have different views, let us know. I think it's important to start from there.
Yeah, no, I really like the idea of standardization. I think it's really important, to have something established and on a WMO webpage that people can reference, that they know that it's known, it's proven, it's consistent. And there's also space for, stuff that's developed experimentally that can be recommended for people to try and test out. So I think one thing that I'd like to also see is a process for modifying RGBs. I'm going to mention a potential really pain point. Is the modification happening because there's actually a training issue, or are you really trying to fix a limitation that's within the RGB? Because once you modify that RGB, you're changing the color intensities, you're changing the thresholds, you're potentially changing the interpretation of other features. So you're really almost creating a new RGB that you really need to understand the downstream effects of that. And so, you know, I think part of modifying RGBs is to understand the impact on other features, and then to understand the seasonal and diurnal implications. Are you fixing it just for the winter time? You know, what happens if you then use that modification at another season? And what happens day versus night? And then what happens regionally? Are you just fixing it for your location too? So there should be a little bit of extra verification that goes into it, and a little bit of care when doing it. Okay, so as the other thing is with the harmonization, when the air mass first came out, I was like, oh, this is beautiful, you know, and we kind of went down the path of having separate recipes for JMA and the GOES-R series. I don't know if those are necessary in a sense. I know some of the work that I showed, you could see a demarcation, you know, and you showed yours there and you didn't see a demarcation between severe. But I think we have to be careful about which ones that we need to change recipes across sensor and which ones we don't need to, because that causes a lot of confusion. I think one thing to do is really focus on some of the problem bands. You know, 3.9 and 8.6 seem to be the problem bands that any RGBs that have 3.9 and 8.6 tend to have differing coloring across sensors, because you have different central wavelengths, you have different bandwidths, spectral characteristics that really impact the absorption of water vapor and CO2 and such. So, you know, maybe a place to start, you know, as new sensors are launched and people start to create RGBs from other sensors, really, if it has 3.9 and 8.6, kind of look at it across and decide, is that a point where you need some harmonization and some fiddling to do with? JMA has a really great approach with their regression that they've developed. I have an approach that uses more observations. They're very similar. Yeah, and then when we just create RGBs on different sensors, there's going to be great stuff that comes out. And, you know, just if a good RGB comes out, we want to harmonize it, just make sure it's consistent across.
Yeah, some good points there. Anyone wants to reflect? I have few ideas on a few things. I actually missed to understand that there is a problem across instruments for 3.9 and 8.6, you said. So one thing about you, if I understood you, you're not keen to really tweak too much RGBs and play around. And I would absolutely agree. I don't know if it comes from the longer experience of staring at the RGBs, and as I've said earlier, humans do have this incredible non-artificial intelligence process in their mind. So you were showing corrections for the limb and how well some features pop out. I have to say, from my experience, these corrected versions confused me, and I had bigger issue recognizing what's happening there. I'm fine with this bluish, and I completely work fine with that and completely understand what's happening there. And if someone kind of enhances that, I won't get much more understanding. probably because I have, as I said, 10, 15 years staring at this air mass RGB. So intelligent, yep, Mark. No. Well, I'm just okay. Yeah.
I don't think that's a standardization issue because the MSRGB is defined as that. A limb corrected MSRGB is probably very well understood. What is useful in different contexts is a slightly different question. That the MSRGB is useful, I think it's useful enough that we have a standard for it, which is that. If a limb corrected MSRGB turns out to be useful in the future, cool. If not, well, that's science. You know, let's do something else. And so I think I think it's not a question of standardization.
I agree with you. The reason why I was telling that is to maybe understand the value of having a standard and harmonized set of RGBs that we could discuss easily across the oceans. Yeah.
Yeah, no, I totally agree. That's the standard. You know,
You say that the black pointing to is the MSRGB screen.
that,
Oh yeah, that means the screen, what you're seeing. That's the standard.
yeah, so I totally agree. That's the standard. That's what people are used to, you know, and, you know, there's users that are looking at storms that, you know, kind of cross that region from 40 north up into the higher lats, you know, that they could really benefit from being able to follow a storm with consistent coloring across. So, you know, there's some users that prefer it. There was discussions over here with Poland about, you know, they have issues with highlights using the polar derived imagery and the geostationary imagery because of the limb effects. So there's probably niche areas and niche users that would really benefit from it, but you know, that's the standard there. And maybe in the future, as different RGBs come out and are created with water vapor channels, maybe from the start you could limb correct and, you know, kind of get people so that they have a consistent field of view and consistent coloring.
Yeah, for that reason, it's maybe quite important to have first of all standardized approach how to build the RGBs. What is the logic behind and what are the best practices doing that? Bernie.
Right, and then I was going to say, you know, this would be the content for a web page. We have the standard, and then we have branches off that, so to say, that say these are modifications or niches based on latitude, based on satellite, based, you know, whatever. Okay.
Yeah.
Season.
Yeah. So do you have WMO standards, and then do you have approved WMO? What word do I want to use? WMO niches, like you said, you know, or do you not even want to go there at all? Maybe you don't want to go there at all. You know, maybe there are some modifications or diversions from the standard that are worth having documented and available for people to try.
Mark just did a thumbs up, and I would say yes, you know, and then this gets back to perhaps we'll have a committee to work on the web page, what goes on the landing page versus what might go into something like a Moodle.
So I have two thoughts. One is there's a question online from Garrett, and would it be helpful to go through the notes of the last meeting so we can actually have a look at the standards and go obvious tick tick tick.
I was just telling Maria if she can share. Maria had she put some effort to collect all the RGBs.
Oh yeah, and I have
So let's
those.
go
Do you
through-
want me to
let's go through-
share one
yeah,
of those? Which
yeah.
one?
Okay, we can do that.
Because you sent me 2 documents. You want me to share? Okay, is it one of those or something different?
I'm not sure which one. Yeah, talk with Maria and I'll catch the question from Garrett.
I could speak.
So Yeah, you can speak. Perfect.
Yeah, I apologize if this has been discussed because being in Europe, I have missed most of your meeting in the past couple of days. But we talk here about standards of RGBs, but do we actually have a strict definition on the strict agreement on the definition of an RGB? I'm thinking about things like for example, the low-level moisture composite from ESSL is just a ratio between two channels and then a color map applied. Is that an RGB?
No.
Or not?
So within the traditions of the RGB label, we're normally talking about putting a channel on R, a channel on B, a channel on G, or a combination.
Right.
And there's no color mapping. So the only changes we make are thresholds, ranges, thank you, ranges, and the gamma. So obviously there is probably some scope to have good color maps because that's helpful. And so I could imagine in the future, we might provide, this would be more guidance than standing, and like this is a helpful thing that people find. But for the moment, when we talk about RGB, we're just talking about the stuff put in three different, the R gun, the channel, or I don't like the word gun, RG and B.
Yeah. Is this fine, Khaled?
Yes.
Okay. Okay. The one with the comparison of RGB.
Okay, so I have that.
Yeah. Okay, so because we're mentioning WMO, we had, especially for the online participants, but this is a bit of news for me because I didn't attend open space discussing that yesterday. Is there anyone can share a small bits on, do we have any agreements on WMO web page or centralized?
Yeah, so the idea, I think the recommendation that came out of one of the groups, which if Heike's online would be great, is to ask the space program to provide some place where we can provide a coordinating or standards document. I'm slightly shying away from the word standard because when the word standard hits the WMO infrastructure, special things happen. Translation into 6 different languages, et cetera, et cetera, et cetera. So it's not necessarily a bad word to use. It just, we need to be slightly careful. We may not be talking about a WMO standard, but we are talking about something that we're all agreeing together. Excellent. Or am I fighting with the mouse? Cool. So if we make that full screen, that Word doc, Ivan, don't run away.
No.
Yeah, there we go. Well, all of them. So, Benny, sorry, can I? Yeah. There we go. So, if we just sort of, so are there, if we just go through, so air mass, is there any argument or contention for, is there a question or?
Okay, so we're just, there is on the GMA pages, there is actually the WMO recommendation schemes, but I think it's there.
This is the same as this, yeah. So I'm trying to have one. Yeah.
So
what I'm going to. Yeah.
I think it's.
Yeah, we're good. Cool. Are we okay, Bernie?
Yeah, we don't know.
I think we're good. Let's work on one document. Which let's work on this one. So what I'm going to suggest is we kind of go through these and just see where there is any discussion we need to have. So if we go through the table of contents first, and then we can get to discussion. So air mass. The acknowledged tuning is the tropical tuning. So we have the air mass definition, the tropical tuning. I need a hammer. I want to sell it. I want to go bang. Yeah, hammer.
Oh yeah. Wait.
Sorry, thank you. Based on what Maria has just said, I don't think that variant we should call it tropical air mass, because we should rather emphasize what it is meant for. It is meant really to bring out convection, and mostly very active convection. So because if you consider the channel, it's like the dust RGB, and then the what do you call it? The volcanic ash RGB. It's the same combination, but when you change the tuning, it changes completely, and then you have a different name. So I suggest that maybe that air mass, the air mass RGB, tropical air mass, should be renamed so that it will really reflect what
I'm
it's
going to
meant
propose
for.
a name, which is the air mass RGB tuned for tropical convection.
Perhaps incorrect. You have a nice case study of convection moving towards Senegal and it disappearing because of the subsidence, dry aloft. I remember even Jochen was saying, just quickly, it is not only convection, it is air masses as well. So I would argue there, but I don't know who's...
Air mass RGB tuned for tropical convection, air mass convection, tuned for. But what we'll do, because I want to keep this moving.
Yep.
So the name is not instantly agreed by everyone. But the channel combinations, etc., is clear. Excellent. So this RGB is partially sold, but for a name. Oh, the names are always fun. So Ivan and Hammer, and everyone tropical gets to agree the name, and who gets to declare whether the name is any good? Martial, you're the kind of Bilal, you can decree whether the name is accepted.
Can anyone, by the way, track what we're doing here?
So that's
Well,
so that's the air mass RGB. Okay, so there's nothing contentious there. We kind of don't need to discuss it. Cool. The 24-hour microphysics RGBs.
Wait.
So the EUMETSAT created standard RGB, the dust RGB, and it was retuned. And the 24-hour microphysics RGB it was getting also a standard RGB, because in the dust RGB, many times the low clouds were not seen. And that's why Hans-Peter Rösli retuned it for Europe to be seen, also the lower clouds. So the dust RGB was first of all tuned for dust, and the 24-hour RGB is for the whole day using and see all the clouds. That's why R2.
So if you're looking across sensors, when you do that one across sensors, I'll use an American term, it's a hot mess because of the 8.6, that you get very inconsistent coloring across sensors, because some sensors are 8.7, some are 8.6, some are 8.5. You have very different central wavelengths. So that one definitely needs recipe adjustments across. So
we don't want that you take all recipe as it is. So of course, one has to try to retune it. Yes. Yeah. To adjust it to the specific sensor. And we hope that they will be quite similar.
Yeah.
One has to try it.
Yep.
With FCI and with AB, so whether they will be enough similar or not.
Yeah, I mean, once FCI launches and you try and make it, you may find it doesn't look like Severi too, depending on your characteristics. I guess another question I have is, you have the whole range, you have the 24-hour, the dust, nighttime micro. Kind of, I'm weaving in another discussion. How do you think those RGBs will kind of continue or fall out of place as you create new RGBs in the future that are maybe more optimally tuned to NEF analysis?
Cool. So the question is, how much discussion is required here. Lots of discussion or a little discussion to land a standard. So the current standard basically says these are the channels you should use, these are the approximate ranges you should use, and acknowledges that you have to tune based on your sensor.
Right, and I would add to that list, I'd also add the SO2 because it has 8.5/8.6.
But does it use
And
the same?
some-
It doesn't use the same. The SO2 uses water vapor, doesn't it?
Yeah.
Okay,
And
so
water
let's-
vapor.
Yeah,
so it
let's
has
keep
two.
that one. So it's not.
No, but it does have the 8.5 in it.
Yeah, but it's not a derivative of the microphysics.
It's kind of that higher
So we can get onto SO2, but we're not there yet.
That's
So the-
RGB is.
But it has dust in it.
Yes.
Yeah. So what we're
So-
talking about here, though, just to be a bit clear, is the RGBs that are derived off of the 24-hour microphysics channels. Yes, thank you. That family. That family is such a great metaphor because all the little children don't always talk to each other nicely.
So in the comparison, if we go inside, okay. So you can see that I have not found the recipe for GOES. So here I compare the recipe for the Saviri and the recipe for GMI.
Yeah.
Yeah, I think we
So I
just
don't
use
have
the
my
dust.
recipe.
Okay.
Just a little bit.
That's another point that Bernie said, and
Yes,
I
and-
could agree that we just use the dust RGB. I'm fine with that. No? Okay.
No.
Bojana disagrees.
But the forecaster need also
Yes, from the
local-
user's point of view, it's not okay because it is used mostly to monitor fog or clouds. You cannot see it clearly on the dust RGB. That's the point.
Yeah. Night microphysics RGB is much better than 24-hour microphysics for the low clouds. So I think it's my
But
personal
during
opinion.
twilight, this is better. So I
Okay,
don't know
yeah,
whether
it's
we
consistent,
should go
yeah. But
into
But
the
the
details.
question isn't what is better. The question is how we define.
Yep.
Application is 2 steps away. So this is the definition of a 24-hour microphysics RGB. And I'm actually, everyone seems to be agreeing. But one of the, so range is good, range good. Channel differences, I would also suggest
Good.
need to be expressed as wavelengths. And the gamma, so this is now non-compliant, this table, as of yesterday.
No, wait.
Because?
That still has to be.
Well, okay.
I think it was
We'll get-
decided by a small.
Okay, well, we'll get that. But the gamma is ambiguous as to what that gamma means.
No, these are the UMETs at gamma. Of how to say it.
I shouldn't have said
But
the word. I
they
shouldn't
are
have said the
good
word
gamma.
But let's not talk about gamma. Let's not talk about
Well,
gamma.
no,
You should
and I
only
also
know
want to
which-
say, I
which
want to,
definition is used.
So
at some point, I want to come back to the range again too, in terms of training.
cool. But for the definition of the 24 hours microphysics RGB, there's no discussion. Everyone's agreeing, yeah?
It's fine as a definition. The tweaks for the
For the 8.6 or the 8.6.
So,
8.7.
okay, so how would that be if we just, like, if we're used to calling it the dust RGB and we don't really use the
That's not the dust
microphysics
RGB.
one?
No,
Okay.
we agree
Okay.
it's not.
It's a retuned dust RGB.
Okay.
But we, yes.
Yeah.
Yeah.
So
We'll
hold on. Right. So we've got questions from the audience as well.
I just have a question. What's the issue with the name 24-hour microphysics? Because this is really used for microphysics to look at the type of clouds. Of course, it's not the only thing maybe which does not go with microphysics here is the cloud particle size. It is very difficult here to have a good idea of the particle size, but at least you can have an idea of where the cloud is. Is it water cloud? Is it ice cloud? Is it a thick cloud? Is it a thin cloud? So I think the name 24-hour microphysics, I think we can keep it because it's in my own opinion, if we try changing these very useful RGB names, people may get confused. We have been using these names for over how many years? And then a sudden change. If there is no, I don't think there's a problem with the name. And for the gamma corrections and other, of course, for me, I think the main important thing should be the channel combinations. And then each satellite can use its own tuning. That reflects what is important for the best. For me, the most important thing is that we should have a reference. Maybe a reference that this will be the reference. We should try to tune to get as much as possible colors that are very close to the reference.
So I guess it's up to each sensor operator to agree what its particular tuning is if they want to standardize. But this is, are we happy that this is the 24-hour microphysics RGB? And I'm really like, yeah, cool. There's no, yeah.
Thumbs up. Yeah, and the name
now,
is
so
agreed.
there's dust and ash, which are just different tunings of the, so this is the whole family thing. So the family goes in two different directions. It depends on what 8.N and 10.N sensors you've got. Okay, that's one direction. And the other one is what tunings you're then going to do when it comes to ash and dust, which are going to be localized. So there's the AHI dust compared to the ABI dust and the Severi dust. But we're happy that that's the dust RGB. There's nothing contentious there.
Enough of silence to go on? Or let's not go there. I think it's fine, right? No comments there. Dust RGB, fine.
Yeah,
Small comment.
my comment might be talking with why the US went with 11.2 as opposed to 10.3, but.
On the green.
It's just because it's more powerful like that. That's the short answer. I know I have some ideas about the longer answer, but yeah.
The US went with the 11.2 because the JMA went with the 11.2. That's why we are harmonizing with the instrument that was launched first.
Yeah, the last Tokyo workshop, George Agenčić and Jochen Kerkman had discussion around that, so you can go and revisit if you need more details, but definitely it's more powerful than Severi like that. And I know because oh yeah, okay.
So that's,
Let's do that later. Yeah.
One should test it.
But,
Yeah.
so
Yeah.
that is up
One
to the
should test it.
region to provide its standard. If you're going to do 11 or 10, that's fine. I think we're saying there's nothing in the international standard that says you must use something that starts with a 10, just because it starts with, or an 11.
It's similar enough, yes.
So you need to decide that in your region, but then declare what you are using. Yeah, but the point is here is standards, not otherwise it's going to.
For Severi, we don't have this 11.
Yeah, we don't have 3 window channels, so that's and we won't have with the FCI, so we have to stick to this. Okay,
Yeah.
so
Yes.
we keep it.
And in the JMI quick guide, that there are 2 variants with both. So he is tuned with both. And I remember that Johan Kerkman had an idea which one is better, but I don't.
Yeah, but we need
don't know.
to stop talking about
Okay.
what is better. I
So-
don't care. What I want to know is what gets written down as a standard. So how do you do that in the US, say, with GOES, to say this is what we're going to call the dust RGB?
One has to test, I think, and then.
I thought that was the point of my comment. Is that wait.
But yes, you do test and you work it out, but we need to be.
Don't have to decide it, no?
Sorry for jumping the priority here, but the point of my comment was the U.S. largely adopted the standards based on what JMA had done with Himawari, since that was a highly similar instrument.
Yeah.
So the U.S. standard, if we roll the clock back to 2016, was just to harmonize with what JMA had done. What's better or not, I suspect that JMA and us had that discussion at that time. I don't recall the specific discussion about this, but that our best practice was just because the HI and the ABI were so similar that we thought that was the best place to provide harmony.
Cool.
When we were having the set, I'd had some of that work to show kind of the difference between the JMA tuning, a tuning that I developed, and the Severi. And it was all very close, you know. So the work has evolved since then that I have a NASA funding for it. And so over the next year, as my project finishes up, I'll be able to show whether or not we need to have a GO specific type of tuning that diverges from JMA. So, you know, it could be, it could not, it might not be. So I'll keep you updated on what I find with some of these.
Okay, so there's a thing to notice then that for the 24-hour microphysics family, there is a whole bunch of variation and derivation. So from a standards perspective, it's probably enough to say things like this. There's variant 1 and variant 2. From a standards perspective, what you do with your users to make sure your users have got a clue what you've done is a separate question, but a rather important one. But from the standard side, I think that's okay, as it is there. But and maybe we just need to acknowledge that within the 24-hour, I like the family thing, it's a great metaphor. Within this family, you have to tread a little bit carefully to understand what's going on. Does that feel okay?
Yeah.
Feels deeply uncomfortable in lots of ways.
I just have a question, because since MTG is coming, compared to the other third generation satellites, how is this split window channels variations going to be on?
That's not a question for now. It's a really, really important question.
I understand, because what I'm asking.
But we don't have time to talk about it now.
Okay.
Because we can talk about FCI and what we're going to do, but we need to do that somewhere else. You and Ivan can spend weeks, and will, don't worry. Is that okay? Yeah. Because what I don't want to do is to get into individual. We're trying to get a sort of what's the global idea here. So that's ASH. So that's the 24-hour microphysics family done, sold. But noting that we're going to have some variation with the 24-hour microphysics family. I am going to skip over.
So I guess the question is, my question is then, say if we have this on a web page, do we have to call it the 24-hour microphysics dust? I mean, because that's a really long name. Okay.
It's not called like that. It's just dust. It's just called dust.
Okay.
So just, as it has been for.
Well, I know. So I'm confused then. I'm a user looking at this and you're just calling it the 24-hour microphysics family, and dust is included in that?
Yes. Yeah. So the 24-hour microphysics family all use the same channels with different tunings. The 24-hour microphysics RGB itself uses one particular set of ranges. The dust RGB uses a set of ranges. The ash RGB uses a set of ranges.
Okay.
It's all good. Cool. Yeah, Curtis.
Well, there's a comment from Bodo.
Okay. Bodo, do you want to open your mic? Hopefully we can hear you.
Bodo, you want to speak up? So Bodo is saying from attending the 2012 RGB expert and. Wait, will I unmute you? manually.
Yeah.
How about now?
Oh, great. Yeah, thanks very much for that. Look, I recall at the 2012 RGB Expert and Developer Workshop that was in Darmstadt in Germany. I talked to a number of, like Jochen Kerkmann, for example, and the idea was that my understanding, historical context, was that the 24-hour microphysics was, if you like, the new version of an infrared type product on steroids adapted to the new generation of satellites. Its first emphasis was on clouds, but looking at my lecture notes going right back to 2012, there are two variants to this 24-hour microphysics. The first is the dust RGB that's already been mentioned, using identical channels but with different tuning, and the other one is the ash RGB. So looking at it historically, I think if we now make a sudden change from that, people might, how can I say, there might be some confusion because of that. So that's my understanding. Thank you.
Yeah, cheers, brother. Yeah, I think we're all agreeing with that to keep the names. Cool. Alrighty. Yeah. So 24-hour microphysics RGBs is kind of in the bag. Yay. Night microphysics RGB. Does this ever get called anything else?
No. Fog RGB.
Yeah, sometimes this is called the night fog RGB. Are we happy to call it the night microphysics RGB? What's in AWIPS or in the display systems? What's it look like? Nighttime microphysics. That's a level of abstraction I can live with. And there's no discussion really. It just gets a lot of love.
It does. Good.
Big love for the night
We've heard that
microphysics.
throughout the week. Yeah.
Yeah. Awesome. Wicked. Cool. The day microphysics scheme. Should we do the day microphysics schemes? So.
Not really. I haven't seen that. Oh, wait.
There was a question somewhere. I heard a thought.
Yeah, but I think that sometimes it is in day microphysics. I mean, in day microphysics, there is a variation that uses 3.9 channel reflected part only instead of 1.6. It's original. Yeah, that is the one original. Yeah.
Okay, so what we call the day microphysics RGB, which is the VISO 8 3.9 reflected 10.8 or 10.4 or choose your favorite 10 channel. I don't actually think there's no question here either, is there? This is all good and lovely. Excellent. I'm just ticking off the easy stuff quickly first. So that then takes us to this new world craziness. The FCI proxy cloud type RGB. Do I? Okay, there we go. The cloud phase distinction. So this is 10.3, Vis 6, 1.6. Actually, there's no question here either, is there? It's sort of become called the day cloud phase distinction or cloud phase. Are we just calling it day cloud phase? What are we calling this RGB? Day cloud phase distinction. That's too long. Day cloud phase. So it's for those of us in Europe and Africa, we don't use this yet. It's the future. Yeah.
Yeah, day cloud phase distinction. Yeah, and I will say this may not be the right time to say it, but for training purposes, the day cloud phase distinction versus day cloud phase type, that's going to be something that we will have to consider for just training purposes on making sure forecasters can discern those two.
So there's those two. Maybe get rid of that. Can we see together? Yeah, there we go. So there you go. That's the difference between the two. Okay, so it's day cloud phase distinction and day cloud type. Okay, cool.
I guess what are they both trying to get out?
Oh, sorry.
I'm sorry. Day cloud phase distinction is more like what, cloud top temperature? Any microphysical info? Both? And then is cloud type also getting at the same thing, or is that just high, low, middle? Not so much temperature. So I don't know if you want to
Cool.
better distinguish.
So are these now acknowledged RGBs that are part of the standard just because they've had so much use within the, I sit in the, what I would call the middle, so east and west, depending on where you are in the globe, of course, that's different. They've got so much traction in history, they are the standards. And those of us in the middle, we're just going to have to live with this being the standard. And if we want to innovate, we'll have to have a different name. Yeah?
Yeah, well, just a conceptual question. How do we go about recognizing there are several RGBs having the same information or very, very slightly, in this case, this is, say, less powerful version of the microphysics RGB, for instance.
So that's not a standards question. That's a user guide and training question. But it's an important question.
But yeah, when do we take it? That's just an open question.
You know, day microphysics versus cloud phase distinction is a very different name. So, you know, and then cloud type, like you said, how does that give a user, well, I mean, it's a user issue, like you said. How does that let a user know, you know, the power of one over the power of the other?
Do we shoehorn them into a family? We're using family in a different way now. This is the family of kind of RGBs you use during the daytime to look at clouds and their properties.
Yep.
Okay.
Well,
cool. So I mean, families. Okay.
Families good.
Cool. So we'll have to think of a name for the family that isn't too specific and won't stress us all out. But it's the family of clouds, the family of RGBs that we look at during the day to look at cloud property type stuff. The day cloud property RGBs.
I have a question.
The night cloud property RGBs is a very small family. Yeah, Bodo.
It's Kevin, I think.
Oh, Kevin.
Okay. Sorry.
This is Kevin Field.
Please go first.
Okay, Kevin, go first, then Bodo.
So Mark, I just wanted to understand what you were saying. If we're not going to decide if something's useful or not right now, then are you going to decide later if something is not useful and therefore take it out of the list of baseline/standard RGBs?
Yeah, I mean, I'm assuming what hasn't happened at this point is no one said, no, we don't use that. I'm waiting for that moment. But I think you're right. No, we would have a process where if in the future everyone goes the day cloud land, none of us use that anymore, then we can just depreciate it a bit, put it in an archive section and slowly get rid of it.
Yeah, maybe kind of like what Emily was alluding to before. I might not be as familiar with every one of these in this family, so I'm not sure if I could adequately speak to if one is or is not dramatically different from another and therefore useful. So if you don't want to decide now if it's useful or not, I just want to know if there's going to be a time at some point that someone's going to say, like Maria was saying, the best practice is to have things that are RGB standards that are different enough that there should be an inclusion of that one. Is there going to be a decision point later that says these two are so similar that we really don't need them as both standards?
Yeah, I would suggest every time we meet, we can have that conversation.
And even I had it mentioned on the slide. I was thinking about if there is a will to have a working group or a task force to kind of track these things in the next year or two and just spit out some ideas in the meantime before we meet the next time.
And that could probably cross with a web page working group because that
It's the
type
same
of information would go on the web page.
Cool. Bodo, did you have anything you wanted to mention there?
Very, very quickly, and hopefully, please, my CIRA colleagues, I hope you will not take this wrong. I don't want to, how can I say, in any way politicize this, but if we go back in time, and I'm looking at my VLAB presentations, I've got a presentation going back to December 2015, which talks about applying the cloud phase distinction RGB, which is, of course, the term used by the by JMA. Now, the serial product, that is one that uses the same, I believe, bands, but is more recent. So should there be some reference to the history here of this particular product and its later adaptation in the final naming?
What do people think?
Well, my question is kind of similar to that. So we have these sources here, and JMA is a meteorological agency. SIMS and CIRA and Andy Heidinger's recipe are not.
Yeah.
And even JMA has different variants. I think one thing that would be helpful, because I'm even having to go back and look at my documentation, is an indication of, I don't know if we want to use the word standard, but whatever NOAA has implemented. And I believe it's always what the SIMS quick guide is or the CIRA quick guide is, but it would be good to know what JMA has 2 variants. Have they implemented both? If not, which variant have they implemented? Instead of saying SIMS and CIRA, I understand that's the source of this data, but we should really say that's the NOAA standard, for the lack of a better word.
Yeah. I think
can I make a very, very quick comment? And apologies for butting in on this, and I'll be very quiet afterwards. But the thing that comes to mind to me, we develop a lot of teaching documents, right? And we update those. And in the beginning, or in some part of that document, we actually put a small history inside it. It's just a paragraph or something or less, giving the original version and when it was updated, and maybe just a quick reference. I wonder to what extent that could be useful.
Yeah, I mean, I do think that kind of thing is useful, but I think it probably slightly outside of the standards place, or it's like in an annex or in the footnotes or something.
I don't know what aspect is outside. I think the history is outside of the standards. I think that you can make the case, and I'd be open to opinions from other in this room, that the meteorological agency should indicate a standard for their forecasting purposes. And I understand citing the source of how we came up with this data, but it would be good to say this is the NOAA implemented definition and the JMA implemented definition, and same for Europe.
And there might also be, so we might have something that's commonly used in Europe, but there might be a slightly different version that's used by somebody else, and they can say this, whether, you know, the KMD implementation of this is actually this tuning.
Yeah, that's the tool for the task force, maybe the document control.
Cool.
System.
So that's day cloud phase distinction and day cloud type. Those are now the names. Yay. The day microphysics RGB. There we go. That's all good. And I'm looking for. Where's dayland? Ah, there it is. Okay. So the proposal is to depreciate the name natural color in this context. So this is the 1.6.86.64. To depreciate calling that natural color, that mostly affects us in Europe and Africa, and to start calling it the land cloud. How do we feel about that? Because natural color gets confusing between, are we talking about the true color or the natural color? So there is quite a confusion about which we talk about. So the one with cyan clouds, we start to call dayland cloud. I'm looking at Team Africa mostly because, yeah. So there won't be a natural color to be confused with. We'll just have to tell everyone this is what this is now called. In 10 years' time, we can then start calling something else natural color. Yeah? Wait.
I'm sorry, but I'm not very comfortable with that, because as for now, we don't have the true color. So, and in my own opinion, as for now, we keep the natural color, and then maybe the change can come later. That's my opinion.
The reason to this is you're not changing the recipe. You're still having this data.
No, not the recipe. Yeah.
The reason to change the name is in this hemisphere, the natural color means white clouds. So it's confusing. There are different implementations of it. Dayland cloud means the one with cyan clouds.
Oh.
It comes to the same. Cloud naturally.
Yeah.
He's thinking he has to go back.
No, he's not. So we give ourselves time to put this in,
Okay.
implement the change. Yeah, Yasin.
Yeah, just was comment from Justin on the natural color enhance, which has the white clouds, but that's just photoshopping
Yeah.
the natural color RGB. Yeah.
Yeah.
So that's history, I think.
Yeah. Okay.
Thanks.
You happy, Hannah? So this is we can change over a decade. We get a decade to change. Yeah. Okay. Cool. So that yeah, Curtis. Yeah. Okay, Bodo. Yeah.
Oh, just very quickly, because at the Bureau we do refer to the natural color RGB, how about as an intermediate saying in the near future calling it the Dayland Cloud, open brackets, natural color, close bracket RGB? Would that help? Or would
No.
that be too long-winded?
No, because in the US, the natural color has white clouds.
Understand.
So we can write a note that says historically this has been called the natural color in certain contexts. And you're in your operational agencies, you're going to do what you do and call it what you call it. But we just sort of over time depreciate that name.
Yeah.
Does that sound okay, Bodo?
So Bodo, this is Bernie. My suggestion is that if you wanted to include something, say even in your quick guide, you could put a star beside the name and then put prior to 2022, this was called the natural color RGB. So maybe put a timeline, which helps the user as well as you.
Yeah,
that sounds good. Thank you.
Yeah, version control.
RGB version. Oh gosh. Cool. Okay.
WMO will have a lot of work.
Yeah.
Wait.
Even for the future changes, I'm not very comfortable with Dayland because we use this much for vegetation and then maybe flooded areas. So when you say land alone, it seems you are rejecting the vegetative aspect. And in my opinion, land is just the land. It doesn't comprise the vegetation. I may be right. It doesn't comprise? Okay. Then I'm okay with that.
We think about it like a land and sea. Land and sea.
Yeah. I'm not going to
with trees and rocks and whatever.
Yeah, so land cloud, land includes the okay, cool. The HRV fog, this is just a UMETSAT thing, isn't it?
Yeah, so this one plus the other one, they use downscaling, downsampling to 1 kilometer of 1.6, and then you have a high resolution visible with some phase information.
So,
quite used, I think, around Europe.
So it's quite used. That's cool. Does it need to be a standard and in the standard recipe list?
We could have a family of high-res RGBs.
Sort of, yeah.
It's like a present Dayland cloud RGB with some tuning, which is using the high resolution.
No, I know what it is, and we love it.
Yeah.
But the rest of the world doesn't care. So does it need to be an international
So
standard?
it's our own standard, and we can do what we want with that.
Yeah.
Great.
So what?
So we can live it. That's it.
Well, but this gets to, because there's also the stuff that comes out of Bill's head. You know, this sea spray craziness. Yeah, Bill. but what do we do with stuff like this that is interesting? It's worthwhile documenting, but you don't have to worry about it. Everything else up till now, you're probably going to implement in your display system. This is just nice, and lots of people find it useful. What do we do with stuff like this? Oh, an annex! I can feel an annex coming.
Have another document. I mean, that's like the day snow fog one. You know, we made that one because we didn't have the 3.9 reflectance. So that's a good case where having it documented that if for some reason you can't implement the Hey, that's not on the list. Your day snow fog, is that on the list?
I don't know, but that's why we should have a bigger list.
If for some reason you can't implement the UMETSAT day snow fog,
This one, page 18.
snow RGB, it might not be the same.
But okay, so we're now going to have an annex in our
So-
document, which is other RGBs that are in use.
Yeah, other
Okay.
RGBs that are in use have been well tested with users, you know. Well, and then you have your cool stuff.
So this is focusing on geostationary satellites. We have different recipes for polar satellites. Tuning, I mean, totally different recipes. The snowmelt RGB, for example.
Yeah. This is true. Okay. Cool. So we've got an annex that will contain other RGBs that are in widespread use. Taking Curtis's thought of what's the agency, what's the definition.
I guess I'm a little confused about putting it in an annex. I think it should be in an annex if it's been formally implemented. But for example, if the US decides to adopt the freezing spray RGB that Bill developed, then shouldn't it be in the main list?
What do people think? Main list? Hands up for main list. Main list? Well, I think Jordan's point is you don't need to. Just put it in there because people can choose to use or not use. Yeah. So it just goes in the main list. The fact that we're not using it is fine.
So no annex.
No annex? It goes
No
in
annex,
there.
annex, no annex, no annex. There's room for annex.
There's always room for an annex. I'd love a good annex.
Or purgatory. I think there's a room for an annex for place that has been developed and is in the process of being tested, right? So, you know, maybe there's something that we come up with that's novel, you know, and we aspirational, like this has promise that we're trying this modification and we want you guys to try it too.
Yeah.
You know, maybe if you also implement it, then it can be moved over to the standard list.
So it's the fun stuff.
Yeah, but the fun stuff can happen also backstage, and it will happen anyhow. And
But
with time, maybe
there is an advantage to having the stuff that's prototypes, candidate, whatever, public. So yeah, Emily's just saying, go on then.
Is Kevin?
Yeah, go on, Kevin. Sorry, Emily's just, Emily first, then Kevin.
Kevin's probably going to expand on what I said. So, you know, we did this in this region, and we need to know if it works for other regions. It doesn't work for other places of the globe. I think that's super valuable to have that info accessible to people.
Cool, Kevin?
Yeah, I think following exactly what Emily's saying, I'm just going a step further and saying a differentiation between whatever lists you create perhaps can include some level of vetting, whatever this group decides is enough, hopefully through various testbed activities, as Emily has suggested. And I guess I would hope that there's some amount of reviewed science that is behind the things that are in the main standard list versus those that are in the, we think this might be good, we think this might work kind of list. I mean, Lenski and Rosenfeld did all their publications of a lot of the Severi standards. I'm not sure how many other publications exist with the RGBs that you're talking about today, but hopefully those RGBs that are in that standard list would have some amount of references that are somewhere in that testbed, vetted, peer-reviewed type of category. That would be my hope if I was a user that was coming on and trying to pick between what is going to be an ever-growing list of 20, 30, 40, 50 RGBs.
And I guess there's a natural thing of actually having that list in the, yeah, Amy. Sorry, Emily.
Connor brought this up about applications readiness levels. NASA uses like applications readiness levels, technology readiness levels. Task force might come up with something super simple in your list that, you know, 1 through 5. This has been tested once, you know, this has been tested over several years. This has been tested and documented and even have a paper that's been validated. And once you reach a certain application readiness level or science readiness level, pop it over to the main list.
Okay, cool. Okay, so things like, so we'll pop the fog in then, but that'll be in the family of, what did we call the day cloud looking at stuff?
High resolution family.
The family of looking at clouds in the day. Day cloud property.
Day cloud properties. I think
Yeah, day cloud property. Okay, cool. So now we're just going to scroll on through. See, Maria, you've actually done most of the work by bringing this together. We just need to, this is the web page mostly written. This is lovely. Dust we've done. SO2, this SO2 thing. Cool. Should we talk about the SO2? So I don't know this very well. So this is a water vapor infrared difference temperature thing.
It looks like the air mass RGB version. Slim.
Yes. It's in a sense, it's similar to both the air mass and the dust RGB. Because the air mass uses the water vapor difference, and I forget what the rest of it is. But then the green and the blue are real similar to the dust RGB.
Yeah.
No,
but it's fine.
It detects dust, and I can show some examples.
So I think to link it into those two families.
No, but the dust RGB does have the same green,
yeah, but
and it may even be the same range.
To link it into the microphysics family.
And it has the same.
No, I'm not arguing whether it's a step. I'm saying it is not a good
So the point being, it doesn't fit in the microphysics family because it does not use those channels. It's not saying, and it's not the MS RGB. It is the SO2 RGB. Okay, fine. So this one's never been on the list before. So this is a candidate for inclusion in the list. Is there any evidence that this thing is any good?
Yes.
So one person says yes.
I also say yes.
Nodding. Yeah, Jose's waving. Okay. It's more than a 1. It's at least a 2 on this 5-point scale of maturity.
It's one of these ones that was picked up at the last workshop. And it's there because SO2 is important for volcanic ash, and it's one that was developed by JMA.
Cool. So let's have.
Although there was no background information on it, so that's why it's not popular.
So we've got Jordan, Emily, anyone else, and anyone in the chat? I can't quite see the chat.
I think again, the US JMA have implemented these nationally. I think that that's a sufficient justification to include it.
There we go. Yeah, and
so it's included.
It's included.
It's included.
And the SO2 RGB is a good enough name for it in your experience so far?
Yeah, well, we won't go into what it can detect, but just as a name, I think it's fair. Because we have a volcanic ash RGB, and we have a dust RGB, and we have a whatever. So my opinion would be it's kind of, yeah, it separates from those. And
we were talking about this yesterday. What do you do with multi-purpose ones when they're equally as good for two things?
So Bodo is agreeing that it's useful. Thanks, Bodo. Okay, cool. So it's in, and it's reasonably standard, and it's got a tiny bit of provenance, and it's again demonstrating why we need to have some documentation of that history so that we know why can we stand on this thing. Ash we've dealt with. Simple water vapor RGB. So again, it's in the list. So this is the Jordan principle of if we're using it, it's in the list and we're sharing that knowledge. Is this used?
Yes, it is used.
The only thing I'll note, other than perhaps the American versus British English of the word vapor, is that I believe that the JMA and the US recipe are exactly identical. So I don't even know if we need to separate them because we've just completely implemented the same thing.
Okay, cool. I like the word simple. That's cool.
Alrighty, so differentiated water vapor RGBs, same comment. So this is now the family of water vapor RGBs, because you've got two.
Are there users for this, all of these?
Yes,
Yeah.
in the US, yes.
So can that be part of? Can along with the air mass RGB, could we have a family of water vapor RGBs?
Yeah.
Simple differential. One thing to consider too is kind of maybe an approach for when you use that water vapor difference. Scroll down just a little bit, because the differential water vapor and the air mass use the same red component, but there's a inversion and such that takes place that if you switch the order of the difference, you would get the same thing. So
Yeah. Okay,
yeah.
so we just need to be, this is the kind of thing we need to point out.
To point out. So you kind of, with the differential water vapor, having the difference the opposite way and then also inverting it, it creates difficulty with users on how to interpret it, because if they understand how to interpret the air mass red component, then they would understand how to interpret that component.
No, that's just clear. So that's fine.
So thank you very much. I was wondering, I'm putting myself in the forecaster perspective. I was wondering if these two RGBs cannot be named better. I don't know exactly which water vapor they see, but it seems like the first one we have channel combinations in the mid and the upper troposphere. And then the other one, it seems we have, we use up to the 10.8. So maybe I don't know whether the water vapor we see is related to the atmospheric layer, in which case I think we should relate it to that instead of simple and differential. That may be confusing for the forecast. I don't know.
Emily?
Just quickly adding to this, we will have 0.9, we'll have GeoXO will have 5 point something, so we'll go deeper into the atmosphere. This is just to heads up.
Yeah, so we had forecasters look at these, and with a simple water vapor, it was really good for just picking out broad locations of where the water vapor was, and the forecasters actually used it to anticipate CI. They could see some of the clouds, the moisture start to bubble up, and some of the clouds start to bubble up. So whether or not simple water vapor is a good name to give you an idea of what it's used for, maybe you could call it, I don't know, convective initiation water vapor RGB, I don't know. But differential water vapor, I feel like that one is a really good name, because I have a poster from a couple years ago where I compared it to the air mass RGB for a couple cases. And so the air mass RGB gives you the kind of the horizontal extent of the water vapor. Differential water vapor gives you the up and down. And it's beautiful. The differential water vapor, you don't get good gradients in the horizontal, but in the vertical, awesome.
So Google for Phil Chadwick, right? He's the guy doing the 3D water vapor.
So the simple water vapor, there's a question about the name. I guess that might be just because it's not very future-proof. In the world of GeoXO, we might have a different thing that we want to call the simple.
Future-proof.
So there's a question mark there. But okay.
Can I say something?
Yeah, please.
Yeah, first, as note of order, I've had my hand raised for a while, but it seems nobody's noticing. And in the chat, it says the chat is disabled.
Oh.
So that didn't work either.
Well,
but,
just interrupt us. We'll stop.
Okay. Okay. If I should just interrupt when I want to say something, then I can do that as well. Yeah, I was wanting to say about the naming as well. I mean, I think some of the names are confusing to new people because they have a certain name, but you see lots of other things in them. I mean, in the ash RGB, of course, you see things that are not ash. But changing them would be confusing for people who are used to the names. So does that actually get anywhere? I mean, are we making a set of guidance if somebody provides a new RGB to not give it a name that then gets used and therefore others cannot use that name anymore because it would be confusing, like with the natural color?
It's a valid question. I have no answer.
Yeah, I mean, I think that we're learning from experience. The guidance is to be a bit careful with the naming.
Yeah, naming is a big problem.
Hence the question mark on simple water vapor. This feels like something that's going to bite us in the future.
So that's relatively new then compared to something like ash or SO2.
Where it's been going for 20 years, I guess we're kind of stuck with the name.
Yeah. Okay, so then we would
ocean.
Yeah. So those we would only change if the same thing means different things in different places, like natural color, and otherwise, even if the name is not optimal, if it's used worldwide, then we're stuck with it.
Yeah, we were making precedent with here with the natural color RGB, but it takes time to change and make for the other one. We likely won't be just switching from one recipe to the other with the same name.
Yeah. Okay, happy if we move on to fire? Fire, ladies and gentlemen. So this is the fire temperature RGB, which I think there is no debate over. People are happy with the recipe and the name.
Yeah, that's the same.
Cool.
Just a different.
So are there any other fire RGBs that anyone would like to promote as being interesting, Curtis?
Yeah, so I would like to promote the new Day Fire RGB that uses 3.9 as the red component, the 0.86 as the green component, and the visible band could be 0.6 as the blue component.
Is that the one that the goal is to bring smoke in?
Yes. Yeah.
So the idea is to bring the smoke up.
So so you're aware there's discussion. This could also be called the day, land, cloud, fire RGB if we really wanted. But day fire seems somehow.
Yeah, day, land, cloud, fire is the name that's being used in the U.S. currently. But I would propose that we rename it to Day Fire.
Yeah.
And I had the ideas of you've seen the 24-hour fire that would have some intensity information from 3.9 and 10.8, and the other is freeing up the 1.3 from the fire temperature RGB to get some cloud information, be it brightness, temperature difference, or 10.
So is this something that's used at the moment in operations?
No.
Cool. So this goes in the annex. Okay,
yeah,
cool.
This is annex. This is not annex. So we should put it on the list immediately.
So
yeah.
We have two lists. In this list are where I found quick guides from different sensors. So I have another list, a more broad list.
So it's probably in there somewhere. Yeah, cool.
Yes, maybe
something
similar.
So the proposal is that the day fire goes in, which is great. Thank you very much. And any other fire, because fire is going to be something that grows. That's the wrong way of saying that. The use of the fire RGBs and different fire RGBs to support less fire growth is going to be something that we see more of. But the candidates and the documentation behind why these are good need to see on the annex. Okay.
Yeah, that's like 2 years down the line, especially with EPSI.
So night microphysics we've done, day cloud. I'm looking for some chaos that I know is in there somewhere. Come on, where is it? Oh, here it is. Okay, what is this RGB called?
you have what? Yeah. Day convection.
Can I just perhaps make an interjection? I apologize. I should raise my hand, but it's really I think Jochen Kertmann developed it. So my understanding is going back a long time. Is it worth asking Jochen for his opinion, if indeed, if I'm correct in saying that he's the originator?
We can do. What did he settle on in the end? What did he? What did
On
he
the
talk-
name,
Yeah.
I don't think he had a strong point.
Yeah, no. But we do. I think this probably does need to have a consistent name because I've seen it called the convection RGB, the severe storms RGB, day convection RGB. It seems that today we want to settle on day convection. Yeah, yeah, cool. Day convection it is, and otherwise there's no real contention there. Obviously it's got the 3.9 in for watch out for that. Is the R 3.9 R or just the straight 3.9?
It's the only 3.9 reflected. So this is a poor man's version of reflected.
Cool. So the standard recipe, this gets down to who's implementing what. If you've implemented 3.9, you're going to say 3.9.
And it's no. I think it's fine actually. No. I think it's fine. It's fine. Yeah,
So the question was, has anyone made it with 3.9 reflected?
No. You're not. You're right.
3.9.
Day microphysics has the reflected one.
Okay.
Yep, good.
Cool. I think that is actually the entire list, isn't it, that we've gone through?
Oh, Maria has more.
Well, so are there any other RGBs that are in common usage that need to be on the list?
Yes, I would propose adding true color to the list.
Yay.
So
we're going to get the other.
It's not there? It's the other list.
Alrighty, so here we go. Bernie, can I have the?
But of course, it should be a standard.
Can I make a quick comment?
Yeah.
So one of the subgroups yesterday discussed true color. And since we haven't briefed that out yet, I will say, and those who are in it can correct me if I'm wrong, but I believe we agreed that any RGB that uses red for red, green for green, blue for blue, or attempts to approximate any of those or modulate any of those or perform Rayleigh correction on any of those, any of that be termed true color. Wasn't that the agreement? Yeah, and we all acknowledge that it's never true. It's always false true color. That's okay. But I think just to be on the same page, that's the simplest way.
And so what we will have in the recipe is the different operational agencies and their implementations are just going to be there. So what we do with FCI, what is done with ABI, AHI, AMI will all be fine. Emily, did you? Yeah.
Complementary to that, does GeoColor classify as an RGB, and does that need to be on the list?
Cool. Okay. This is sorry. The GeoColor cool question is how to classify it.
Very cool.
So GeoColor is a special class for a variety of reasons. Number one, it includes a nighttime component, which is not really an RGB at all. It sort of is, but it also includes ancillary data, the lights background, the elevation data set, and the shallow water versus deep water versus land data set. So it's it's more difficult to calculate. I don't know if it belongs in this list or not. The daytime component is true color.
Yeah.
But I don't know.
Just a quick reality check on the time.
So it's probably sort of coffee time.
Not because of coffee, but
my suggestion would be to have a chapter in whatever document we end up writing that just describes the GeoColor in a very simplistic format. Because what it does is combine things in a helpful way, and it's worthwhile sharing that. And just we don't need to standard it. Yeah, please go ahead.
Yeah, I totally agree with you, Mark. I mean, it's a separate category of things that go beyond the whole basic standard RGB thing and adds a whole slew of information. I think Curtis described yesterday that many different levels or layers of data can be added to it. So you could do this with a whole host of other RGBs to put quantitative information in some layer, which a lot of people want. So I would say it's separate.
Yeah, Bill had also many ideas and others about level 2. So it's a family.
Yeah. Well, it's not a family of RGBs. It's a different way of doing things.
Okay.
It's just a way of.
Yeah.
Yeah, but we should, well, the way this will work is we put it in the document now, we get another few years of experience of use, and then we'll probably end up with a list of geocolors. Of these are geocolor implementations that are working really well in operations. Yeah.
Yeah, that's a challenging one because even if you look at the quick guide, there's no standard recipe like this.
Yeah.
That's what makes it.
Yeah. But to have it described, I think would be helpful. Is there anything else that needs to be not in the annex, but on the core list that we didn't yet mention? Day snow?
Day snow fall.
So that one we haven't mentioned. I mean,
Yeah,
we have mentioned, sorry. What?
Day snow fog, and you call it day snow. Ah, okay.
Okay.
And so it's operationally implemented, so it probably should be.
So we can, yeah, okay, cool. Yeah. Okay.
Which is what we have in the US weather service.
Yeah. So the colors don't match exact, but close enough.
Jeez,
oh yeah, sorry.
Cool.
I was just saying that that's the one that we need the table for the US implementation so that other people know that if you don't have a 3.9 reflectance, you can use the 3.9 minus 10.3 in that blue component.
Yeah.
That it's been well tested.
Cool. Okay. So we've actually gone through the whole list and we just need to edit. If we edit this document and add words, thank you, Maria, for the tables, we actually have most of what is being called the website. Any comments or thoughts? Anything left over that we need to discuss this morning?
Yes. Yeah. Don't know if we need to discuss it this morning, but I had a technical thought. I'm thinking of the CF conventions. I think some of you will be familiar with those. They're actually on GitHub, and that's a great platform for discussion and for fixing typos. And I wonder if that's an idea for those standards once we have a document.
Yeah.
I don't know if here's the right time to discuss that, but it's just a thought I wanted to throw into the room.
Good. So to edit this document or just in general?
So when there is a standard, I mean, I think standards have versions probably, and in general.
Oh, for document shop, yeah, we can do that. I mean, we could use the UMETSAT kit or another kit for doing that. It's a good idea. There was a couple. So Curtis had something he wanted to mention, and Jose, yeah.
Yeah, I was just looking at that since we already decided to change the natural colors to daylight cloud. That natural fire colors should probably also be changed to daylight cloud fire. And then, day fire, yeah.
Yeah, day fire.
Just to be consistent with our change.
Yep. Cool.
Okay, Curtis,
yeah. Okay, Bodo, yeah, please go ahead.
Just very quickly, we had Katie talking about people who have vision impairment and the RGBs that need to be created from that. I think that justifies us actually having an annex if we're going to include that.
Yeah. Yeah, and that we had a lot of discussion about vision impairment yesterday, which hopefully will come out soon.
Yeah, are some of these RGBs that are mentioned here the ones that are for vision impairment?
No, these are all the standard recipes, so these make no account.
Oh, because I thought like the water vapor differential one was one that was more tailored towards those with vision deficiencies, but.
I think it's more usable in that context, but we haven't taken it account in this list.
Yeah, the color deficiency is probably a good discussion to have about how to handle variance. The question about the naming, I think, is interesting because if I understand the need the desire to harmonize names, but if JMA has implemented one nationally, this goes back to the standardization question, wouldn't it really be up to JMA to tell us that they've changed the name of theirs? Because we have all these different variants. I mean, I understand the need for international harmonization, but for those that exist, I mean, we could change the name in this document, but that doesn't necessarily mean that JMA, and same thing for NOAA.
Yeah, no, that's very true.
Although in that sense, for the natural colors came out of UMetSat initially.
Yeah.
And so you can change name and then ask others to harmonize.
We can then change it for ourselves. Whether any weather service will change that name is entirely up to them. I think these names help us talk internationally, and they help somebody who's trying to develop a display system that's used across a whole bunch of countries to go, I mean, it might actually be helpful to say this is known by this in these countries at this time, you know, that kind of thing. But I think this helps us to all have the same conversation.
So now are we going to continue this conversation after break a little bit more?
What I think we're done on the standards.
No.
On the standards, yeah.
On the list, but not all the standards, because I want to read. Okay.
There is still one RGB left, which is operationally used and is also on the UMetSat list. It's called high resolution visible clouds, or overview sometimes. So the overview RGB together with night overview from VIRS data, this RGB is used operationally because you have some information also during night from the infrared channel. So
we'll add that one.
Yeah, so this one.
Cool. So anything else to do with the actual, just writing the recipe list?
Well, it's a list.
So you need a microphone.
Just last comment, it might be good to include maybe 2 color vision deficiency ones. So the air mass that we wanted seemed like it was pretty well tested and forecasters like it. And then the dust version that Bill has created.
Cool.
I think those would be valuable to add. And we can note with a simple water vapor that people with color vision deficiency tend to be drawn to that one and can easily interpret it.
Yeah. Or we can put that in the list with some description.
So air mass and dust.
Yeah.
Okay.
Cool.
Good. Do we have people here that would just to have an idea to join the task force and maybe have some exchange in the next years on the specifics of?
Yeah.
Okay, we have some people here. Good.
I'm quite.
Yeah.
Sorry, I'm quite happy to do that also because of the fact that, you know, I went to the 2012 expert workshop, so I have a little bit of historical depth that way. And I'm actually the secretary of our owners corporation here, so I'm pretty, you know, I've got a lot of experience in classifying things, so I'd love to be involved in that too.
Yeah, thanks for that.
The action would be initially to take Maria's documents to refine it in line with what we've just discussed now, as well as discussions we're just about to have, so that it can be in the report of this meeting and then get out on that will then be its first publication out on the WMO website. And we work from there. Cool. So issues we want to pick up after the break then. Bernie, you had something?
I know that you discussed the gamma and the range yesterday, although I want that to be fully discussed here.
Okay.
Yeah. Because I have some points I'd like to present from a user interpretation point of view.
Cool. So we'll get into, after the break, we'll kind of get a bit more into the open space discussion, just pick out the stuff that needs to be summarized from that. Dan?
Yeah, I was just going to say, we are prepared to have the open space discussion, sort of the wrap up of that after the break as well.
Cool. Have you pinged the Google Doc around everybody?
Yes. It's in kind of rough shape. I didn't.
That's fine.
But there's words at least.
Yeah, there's words in a document that people can open. Cool. Okay, let's break until.
Do we need half an hour or 15 minutes? We could make, let's go 10 after the hour.
Cool.
All right.
All righty. Thank you very much.